Hey everyone, and welcome. Have you ever looked way up high at the big, beautiful sky and just wondered, why is it blue? It's one of the biggest questions we ask when we're little, right? Well, today we are going to solve that mystery together. It's going to be awesome. Okay, so let's get right into it. Why is the sky blue? Seriously, it's a question everybody asks, from you and me to the smartest scientists in the world. And guess what? The answer isn't just one boring fact. Nope, it's actually a super cool story about sunlight, the air we breathe, and, get this, a giant game of space tag.
I mean, for real, why not green? Or purple? Or green with yellow polka dots? Wouldn't that be wild? Now, the real reason is a little less silly than that, but believe me, it is way cooler than you can even imagine. All right, every great story needs a hero, and for our story, the hero is a beam of sunlight. So let's follow this little sunbeam as it travels all the way from the sun, zooming through space on a big adventure to planet Earth. Now, this sunlight looks kind of plain, right? Just white or maybe a little yellow. But shh, it's hiding a secret. It's actually a super mix of all the colors of the rainbow. It's like if you took red, orange, yellow, green, blue, and violet paint and mixed them all together really fast. They're all in there, traveling together. So here's the really important part. Each of those colors travels in a wave, but they're not all the same. Think of red light like a long, slow, lazy wave, just kind of cruising along. But blue light? Oh, blue light is totally different. It has short, super fast, super bouncy little waves. It's like it's had way too much sugar. And this difference, this is the secret key to the whole mystery. Okay, so our little sunbeam is cruising through space, no problem. But then it hits a wall. Well, not a wall, but Earth's air, our atmosphere. And our air, even though we can't see it, is jam-packed with tiny little bits of gas and dust. It's a real obstacle course.
And when the sunlight hits all those little air bits, it's like a giant game of pinball. The long, lazy red waves are like big, heavy bowling balls. They just plow right through. But those short, zippy blue waves, bam, they hit one of those little air molecules and get bounced in a totally new direction. And then bam, they hit another and get bounced again. They get scattered all over the place. And there's a super cool science name for this, Rayleigh scattering.
So let's put it all together. The sunlight zooms in from space. It smashes into our atmosphere. It meets all those tiny little air molecules. And what happens? The blue light goes crazy. Those little molecules are like zillions of tiny disco balls. But they only work for blue light. They just throw that blue light everywhere, up, down, left, right, filling up the whole sky. And that's why, when you look up, all you see is that scattered blue light coming at you from every direction.
But wait a minute. If the shortest, bounciest waves get scattered the most, well, shouldn't the sky actually be violet? Because violet waves are even shorter and bouncier than blue ones. If you were thinking that, that is a super smart question. And guess what? Science has a great answer. It turns out there are a few reasons. First off, the sun just doesn't make as much violet light as it does blue light, so there's less of it to start with. Second, our eyes are just, well, they're not very good at seeing violet. They're much better at seeing blue. And third, some of the violet light gets gobbled up way high in the atmosphere. So blue ends up being the big winner we see every day.
Okay, but the sky isn't always blue, is it? We've all seen it. Sometimes, usually at the beginning or the end of the day, the sky decides to change its outfit and puts on this amazing show of reds and oranges and pinks. Yep, we're talking about sunsets.
So what's going on here? Well, think about it. At lunchtime, the sun is right up over our heads. So the sunlight takes a short little trip through the air to get to you. But at sunset, the sun is way down on the edge of the world. So its light has to travel through a long trip through much more air to get to your eyes.
And on that super long journey, that bouncy blue light hits so many air molecules. It just gets completely scattered away. It gets bounced to the left, bounced to the right. Basically, almost none of the blue light is left by the time it gets all the way to you. It's lost along the way.
So, if the blue light is all gone, what's left to see? Which colors are strong enough to make it through that super long trip? You got it, the long, lazy waves. The reds, the oranges, the yellows, and the pinks. They are the survivor colors that make it all the way to our eyes. And that's what makes sunsets so totally breathtaking.
And just when you thought it couldn't get any cooler, it does. Because this whole thing isn't just about Earth. The color of a sky depends on what its air is made of. You ready to take a quick trip around the solar system to see some other skies? Let's go. Okay, first stop, Mars. If you were standing on Mars, you'd look up and see a kind of pinkish, buttery-looking sky because its air is full of reddish dust. Next up, Venus. Whoa, its air is so thick with clouds, the sky would just be a dim, yellowish-white color. And what about Titan, one of Saturn's moons? You'd see a thick, hazy, orange sky. How cool is that? Every planet has its own special sky. All right, let's bring it back to Earth. After all this science, what's the big takeaway? It's that our beautiful blue sky isn't just there. It's not just a color. It's an amazing science event that's happening all the time right over your head. Think about this. Every single time you go outside and look up, you are watching a work of art being made. It's a masterpiece of science painted right in front of you by a sunbeam and trillions of tiny invisible air molecules, all having a giant scatter party. So the next time somebody asks you, hey, why is the sky blue? You'll know the secret. You can tell them the whole epic story of sunlight's adventure. You can tell them it isn't just blue, it's brilliantly scattered light. And that is a pretty amazing thing to know.